In the vast expanse of our solar system, remnants of a time long gone drift silently. Asteroids, cosmic time capsules holding secrets to our origins. Among them is Vesta, a massive asteroid that has fascinated astronomers for centuries. For years we thought asteroids were just leftover rubble. But NASA's Dawn mission, launched in 2007, set out to change that. Its mission journey to Vesta, orbit it, and unveil its hidden truths, findings that would challenge everything we thought we knew. What Dawn uncovered would rewrite the story of our solar system. As the Dawn spacecraft drew closer to Vesta, its powerful cameras began transmitting images that would soon captivate and astonish the scientific community. These were not just ordinary snapshots from space, they were windows into a world that had remained largely mysterious for billions of years, waiting to reveal its secrets to those who dared to look. What Dawn found was extraordinary. Vesta wasn't just another space rock drifting aimlessly through the asteroid belt. It was a protoplanet, a relic from the dawn of the solar system, frozen in time and preserved like a cosmic fossil. Imagine the early solar system, a swirling, turbulent disk of gas and dust, where gravity was the master sculptor. In this chaotic environment, tiny grains collided and stuck together, gradually building up larger and larger clumps. Over millions of years, these clumps grew, merging and colliding, until some became the seeds of planets. Some of these seeds, like Jupiter, gathered enough mass to become gas giants, their immense gravity pulling in vast envelopes of hydrogen and helium, dominating the solar system with their size and power. Others, like Earth, became rocky planets, their surfaces solidifying and cooling, eventually giving rise to oceans, continents, and, much later, life itself. Vesta was on a similar path, following the same cosmic blueprint. It began as a small clump of dust and rock, slowly accumulating more material as it orbited the young sun, growing larger with each passing eon. Deep inside, Vesta developed a dense metallic core, surrounded by a mantle and a crust, layered like an onion. This internal structure is clear evidence that Vesta experienced intense heating and melting, processes that are hallmarks of planetary formation. But Vesta's journey was interrupted. Its growth was stunted, likely due to the gravitational influence of Jupiter. The giant planet's immense pull disrupted the flow of material in the asteroid belt, preventing Vesta from gathering enough mass to become a full-fledged planet. Despite this cosmic setback, Vesta remains invaluable to science. It offers a rare and precious glimpse into the processes that shaped not only itself, but also the planets, including our own Earth. The minerals and rocks on Vesta's surface are like pages from a history book, whispering tales of a time when the solar system was young and planets were still being born. Each mineral grain holds clues about the conditions and chemistry of that ancient era. The discovery of a protoplanet in the asteroid belt was nothing short of a revelation. It blurred the line between what we call an asteroid and what we consider a planet, challenging our definitions and expanding our understanding of the solar system's diversity. Vesta became a window into the early solar system, a time capsule preserving the very conditions under which Earth and its neighbors took shape. By studying Vesta, scientists can reconstruct the environment that gave rise to our home planet. As Dawn orbited Vesta, it uncovered more and more about the protoplanet's tumultuous past, giant impact basins, deep scars from collisions with other space rocks, and evidence of violent events that shaped its surface. These weren't just ordinary craters. They were windows into Vesta's interior, exposing the layers beneath the surface and offering scientists a rare opportunity to study the building blocks of a planet from the inside out. Each new discovery forced scientists to rethink their assumptions about asteroids, protoplanets, and the very nature of planetary formation. Vesta's story became a crucial chapter in the cosmic narrative. Once dismissed as insignificant, Vesta emerged as a Rosetta Stone for planetary science, a key to deciphering the mysteries of how planets are born and evolve. Its battered surface, marked by countless craters and ridges, tells a story of creation, destruction, and survival, a testament to the relentless forces that have shaped our solar system. The more we explored, the more Vesta surprised us. Each new image, each new measurement, revealed secrets that illuminated the story of our solar system's birth and evolution. Vesta's journey from a loose collection of rubble to a differentiated protoplanet is a powerful reminder of the dynamic, chaotic, and creative processes that govern planetary formation. And as the Dawn mission continued to orbit and study Vesta, the story only grew more fascinating, reminding us that even the smallest worlds can hold the biggest secrets about our cosmic origins. Dominating Vesta's southern hemisphere is Rhea Silvia crater, a colossal scar, evidence of ancient cosmic violence. This immense impact site is not just a feature on a distant asteroid, it's a testament to the raw, unpredictable power that has shaped our solar system since its earliest days. The crater's sheer scale and depth are a reminder that even the smallest worlds can bear the marks of titanic events. This impact basin is so vast it could swallow entire countries on Earth. Imagine a wound stretching over 500 kilometers across, nearly the width of Arizona, carved into a world barely 500 kilometers wide itself. The comparison is staggering. If Rhea Silvia were placed on our planet, it would engulf entire regions, dwarfing even the largest craters we know. The crater pierces deep into Vesta, exposing its subsurface layers like a cosmic core sample. These exposed strata are a window into the asteroid's hidden past, revealing secrets about its formation and the processes that have shaped it over billions of years. If Vesta were Earth, Rhea Silvia would dwarf even the Chicxulub crater, the very impact that ended the reign of the dinosaurs. The energy released in Vesta's collision was so immense, it would have been catastrophic on any planet. The impact that created Rhea Silvia blasted debris into space. Some fragments became meteorites that eventually landed on Earth. These spacefaring shards traveled millions of kilometers, carrying with them the story of their violent birth and the history of their parent world. Holding a piece of Vesta in your hand connects you to this distant world. Each meteorite is a tangible link, a fragment of cosmic history that bridges the gap between our planet and the asteroid belt. The crater's formation peeled back Vesta's layers, revealing its internal structure and offering invaluable insights. Scientists can study these layers to understand how Vesta differentiated, how its crust and mantle formed, and how similar processes might have shaped other bodies in the solar system. Rhea Silvia's size, central peak, and faulted terrain tell a story of immense energy and geological upheaval. The central peak, rising from the crater's heart, is a monument to the forces unleashed in the impact, while the fractured surface records the asteroid's struggle to absorb the shock. Studying the crater revealed Vesta was far more geologically active than we imagined. The data from NASA's Dawn mission showed evidence of ancient lava flows, tectonic shifts, and a surprisingly complex geological history for such a small world. Its diverse floor, with variations in color and composition, hinted at complex processes at work. Each hue and texture tells a different part of Vesta's story, from volcanic activity to the mixing of materials during the impact. Vesta's transformation from inert asteroid to dynamic world began with this cataclysmic event. The impact didn't just scar its surface, it awakened geological processes that would shape Vesta for eons to come. Rhea Silvia revolutionized our understanding, showing that even small bodies can have rich, violent histories. It challenged the notion that only planets experience dramatic change, revealing that asteroids too are worlds with stories to tell. And as Dawn continued its journey, Vesta's turbulent past came into sharper focus, reminding us that every scar in the cosmos is a chapter in the grand story of our solar system. When the Dawn spacecraft began its detailed mapping of Vesta, scientists expected to find a typical asteroid, pockmarked, ancient, and relatively simple. But what Dawn revealed was a landscape that defied all expectations, opening a new chapter in our understanding of the solar system's building blocks. Vesta wasn't just cratered and barren, it displayed a remarkable geological diversity, with regions that hinted at a dynamic and tumultuous past. The surface was a patchwork of contrasting terrains, each telling a different story about the forces that shaped this small world. Towering cliffs and deep tectonic troughs encircle the asteroid, standing as silent witnesses to powerful internal forces that once stretched and fractured its crust. These features are not just scars, they are evidence of a restless interior, once alive with energy. Some of these troughs run for hundreds of kilometers, cutting across the surface in dramatic fashion. Their sheer scale suggests that Vesta experienced significant tectonic activity, far more than what was ever imagined for a body of its size. Dawn also detected the unmistakable signatures of ancient lava flows, frozen rivers of fire that once surged across the landscape. These remnants of volcanic activity point to a time when molten rock reshaped Vesta's surface, leaving behind a record of intense internal heat. These features painted a vivid picture of a once geologically active world, driven by internal heat and dynamic processes. Vesta was not a static relic, but a world that evolved and changed over time, much like the larger planets. Most astonishing of all was the discovery of a stratified crust, distinct rock layers stacked atop one another, each layer preserving a chapter of Vesta's ancient history. This complex structure revealed a world with a rich and varied geological past. This stratification, a hallmark of true planets, cemented Vesta's status as a differentiated protoplanet. It showed that even small bodies could undergo processes once thought exclusive to much larger worlds. Vesta's tectonic troughs, ancient lava flows, and layered crust challenged our most basic assumptions about asteroids. It became clear that these small worlds could be far more complex than we ever imagined. Even though Vesta is denied full planet status, it proved itself to be a world of remarkable complexity, with a dynamic and storied history written across its surface. Each new discovery from Dawn deepened our understanding, revealing that even the smallest bodies in our solar system can mirror the powerful geological processes that shape the planets themselves. As Dawn peered deeper, it found bright spots gleaming across Vesta's surface. These weren't just reflective patches, they were regions rich in minerals like pyroxenes, common in volcanic rocks. Even more intriguing was the discovery of salts and hydrated minerals, hinting at the presence of water ice in Vesta's past. The detection of hydrogen fueled speculation that Vesta might have once harbored water. If true, it would reshape our understanding of water's distribution in the early solar system. Vesta, once thought dry and barren, now seemed a potential haven for water ice. These discoveries showed that even small asteroids can hold profound secrets about the ingredients for life. Vesta's bright spots added a new layer to its story, one of complexity, potential, and cosmic surprise. For centuries, scientists studied meteorites, celestial messengers from space. Among them, HED meteorites stood out, their unique composition hinting at a common origin. Scientists suspected a link to Vesta, but proof was elusive, until Dawn. Dawn's analysis revealed Vesta's spectral signature matched HED meteorites perfectly. It was a eureka moment. Those meteorites were fragments of Vesta, blasted off during ancient impacts. These pieces traveled through space for eons before landing on Earth, connecting us to Vesta. This discovery transformed our understanding of meteorites, providing context for their origin. It highlighted the interconnectedness of our solar system, asteroids shaping planets and fragments reaching our doorstep. Studying these meteorites continues to unravel Vesta's secrets piece by piece. Vesta, once dismissed as just another asteroid in the vastness of space, is now recognized as a truly captivating time capsule from the early solar system's formation. The Dawn mission revealed a differentiated protoplanet with a violent, complex history, offering a unique window into planetary formation and evolution. Vesta's story reminds us that even in the emptiest reaches of space, mysteries endure. Wonders await those who are willing to explore and seek answers. Keep looking up and never stop questioning the universe around us, for discovery never ends.